Hey guys, so what you're seeing is AI learning how to play the game Snake. So we have all, played this game in our childhood, in that is mobile phone. Yeah, so that game. So the idea behind this is genetic algorithm, which we will see. But before that, let me just show you the results. Like for the first few generations, the highest score that this snake, a single snake achieved is 2. Like for the first, let's say, 250 generations, the score was a single digit number, right? As you can see over here. But after 250 generations, on the 250, yeah, fly after 250 generations, you can see that at 250 generations, the highest score is 47, right? So after that, the number changed from single digit you know, to double digit number, and it's increasing ever since, right? So I'll test this till let's say 700 generations. I will see the results till 700 generations, and we'll let you know the results in the comment section. But the idea behind this is genetic algorithm, which I can show you right over here. Is the algorithm? How does this work? Is that first you have an initial population. In my case, I have initialized a population of, let's say, 200 snakes. I've initialized a population of 200 snakes, and each and every snake is an object of the snake class that I have defined, and that class has its own brain, which is the neural network. I have used PyTorch to define my neural network, and after initializing, I'm allowing each and every individual snake, like out of that population, 200 population, which means 200 snakes. I'm allowing each and every snake to play the game once, and I'm tracking the score, like which one has the highest score, and based on that, I take a handful of snakes, let's say the top 25% that was able to achieve the highest score in that generation. That means that is the next step, like that is the second step, which is the calculating the fitness value, and then comes the selection means I'm selecting based on the calculation, means the fitness value, which is the score in my case. Selecting a few, let's say 25% of them, right? So I'm selecting them, and so select after selecting 25% of that, I am doing what I'm doing crossover. Crossover means like I can crossover is basically, yeah, you can see there, this is the chromosomes. Just a basic example. Crossover is basically if you have A1 and A2 at the parent. So from A1 and A2, if I create a child, let's say A5, file the first will be the first few like digits. In my case, the weights from the neural network will be copied to the child, and the second, like the weights will be copied to the child as well, like from the second parent, like, right? So from both parents, mother and father, the child will inherit few weights from the mother's side and few weights from the father's side, and then it will go through something called mutation. Mutation is what? Mutation is nothing but I have this, let's say 111 and 000, this number, right? Mutation is basically randomly choosing a single point, let's say 0, and flipping that. That is mutation, and it can occur and might not occur. Yeah, so that is the process of mutation. This is to maintain the variation between among the populations. So after mutation, uh, this is the termination criteria, which is the highest score. I haven't given any highest score termination criteria. I'm running this algorithm for 1000 generations, right? So it will run till 1000 generations. After that, it will terminate. But if you want, then you can, create your own termination criteria. For example, if it reaches beyond 500 score, like if it reaches beyond 500, then you can just simply terminate in the process. But in my case, I'm not doing that. So if the condition is not satisfied, then it will just go to the this one, like The population is already created, so you just calculate the fitness value and then selection, then crossover mutation, and again after mutation new population is created. Like after crossover new population is already created, and then mutation means take a single child and then mutate its genes, and then again calculate the fitness value. Right. So that is how the game is working, based on genetic algorithm. And as you can see, yeah, this is pretty fast. I know this is pretty fast, uh, but that is the whole idea. And as you can see, the score, like the score is increasing. Like it's quite impressive. Like at first, the it could hardly achieve a score of 2 or 1, but now after 300 generations, it is like giving an impressive result. That means my snake has learned. I can say that, right? The snake has learned properly. No, not quite. Maybe it has a lot more things to learn, but yeah, it's giving an impressive result so far. So that is the genetic algorithm. But if you want this code and everything, then yeah, I will link the code to the description below. I will link the GitHub repo in the description below. Anyway, so that's it. That was my Snake AI project. Alright then, thanks for watching. Adios.